This is Advent of Code 2020, day 12. The problem is called a rain risk, and our ship's navigation computer is malfunctioning. We're on this ferry trying to get on our way to our vacation, but there's a storm and they need our help with the navigation system. So, the way this problem will work is we're going to be given a set of navigation instructions, and we need to process the instructions and figure out ultimately, given bearings to go north, south, east, west, to continue forward, to turn the boat to the left or to the right by a given number of degrees. Given any of those actions, we need to follow the instructions until we get to the end of the instruction list, and then produce the Manhattan distance, the sort of absolute values, north and south, added together is north, south, and east, west. Those, the absolute positions relative to where we started, those values added together will be the Manhattan distance, which is the answer to our puzzle. So we'll shoot for hitting 25 with this sample input, and then we can move on to the full puzzle input after that. So I've already gone ahead and put together a little compass just to help think things through. And then we've got our, sample.txt. We'll throw that in here. And that's something we're going to have to read in. So we'll say file gets file.read, sample.txt. And then we'll need to process that file so that we have a list of directions. So say directions get file dot lowercase file dot split, or split on new lines. And then I think we'd like to process it even a little further, because we want to split out the directional values and then the sort of integer values that follow. Oops. So we could map over each of these, call it a line, I guess, or we'll just call it a line, and we'll say line dot match, and we'll match what is it, at the beginning of the string. Then we'll have a capture group, and so we'll capture on just a single character, and then we'll close the capture group. And then we will have another capture group where we capture any number of digits, and then that should be the end of our line. So that's a regex, and then we'll return the captures. So that should produce two things: the directional value, or kind of the instruction value, and then the integer value that follows. And then we gotta close that. And now I would love to try in here and see if we're parsing our input correctly. Not quite. Captures for nil. So line.match. Do we have to go the other way? Do we say regex.match? That may be. It's also possible that we just didn't write the regex correctly. Yeah. So let's hop back here. Actually, we'll copy this and I'll pry in, and a direction could be F10, I guess. And so if we called line.match, yeah, that's sure enough, that's nil. So what if we say north, south, east, east, west, forward, left, right? One of those. Maybe we don't need to escape these captures. Okay. That's what I had wrong. We don't need to escape those captures. Okay. So let's grab that then and replace what we had. Lovely. And so now that we have all this in place, I'd love to create some sort of class that's like going to represent, I guess, just the ship. It'll be a class to represent the ship. I'll initialize it with, I guess, an X position and a Y position, which are just going to be 0 and 0. And then a heading, which for this problem is going to be east. So we'll say ship.new 0, 0 east. And so, yeah, I guess we can capture these in instance variables then. That way we can work with them in our other methods. Okay. And then jump back over here because kind of want to have these directions just to look at in case we need them. Okay. So I guess we just need to be able to process one instruction at a time. So I could imagine, yeah, I guess process instruction is probably some sort of sailing term for this, but we're just going to go with that. And it should be yeah, like an instruction and a value, or maybe we'll just pass in the tuple. And then from that, we'll say heading, direction, and value. Just hesitating a little bit, trying to think of what sort of naming of the domain concepts is going to be most clear. Fumbling on it a little bit, but I think this will work. Destruction in Ruby doesn't have the surrounding brackets, so we'll get rid of those. And now I guess we could just have a case statement on the direction. So when the direction is north, then we say that the X position is incremented by the value. When south, the X position is decremented by the value. When east, then the Y position is, do I have X and Y mixed up? Yeah, yeah, x would be east to west and y would be north to south. So mix those up. Y, y, x. Okay. So east is going to increment us by the value. West is going to decrement us by the value. And then the trickier ones are, so forward is yeah, forward we want to continue to move that value in the direction that the ship's currently facing. So this is where the heading comes into play. So I think that the headings that we'll work with are going to be north, south, east, and west. So I guess we can just have another case statement and say case heading. If it's north, I almost just want to be able to recall like this sort of logic based on where we are. I mean, what if what if we had a function that was like advance with heading and we gave it right, like a direction like that, a direction and a value. And so then we have a function, private method, called it advance with heading. And so it gets a heading and a value, and it does something pretty similar to this. Oops. Pretty similar to all that. Case heading when it's north, when it's south, east, and west. Then we do those things. And so then back up here, we can just replace all of these things with a call to advance with heading. And so then here, what we can do is say advance with heading, and we'll pass in our current heading and the value, and that sort of simplifies things. So then the other two directions we have to handle are left and right. And so that deals with turning the ship a certain number of degrees. So if it were to say like R90, then we'd go from sort of facing east to 90 degrees down to south, 90 degrees to the right south. Or if it was, we were facing east, and if it was L180, we'd go all the way around to be facing west. So we'll say when R, do something, when L, do something. And yeah, that's the question. How do we handle those? So these aren't going to advance our X or Y positions. It's just gonna change the heading. So let's see. Yeah, I guess compute new heading, and we'll give it a turn direction and a value. And so we take our current heading. Well, let's see. I kind of want a hash that says something like east is 90, south is 180, west is 270, and north is 0. Put that on top. And so we get current degrees gets headings to degrees. And we'll give it our current heading. So that gives us our current degrees. So to start, if we're at east, it'll be 90. And then we, yeah, I guess we can just add the value to the current degrees. So current degrees plus value. And then I think we might have to do some sort of modulo logic. So if we had 270, right, we're facing west, and we add 180, I mean, that's too big of a number, or we're not going to want to account for that number. But if we modulo 360, then, oh, we're facing east now. Similarly, if we had we were facing east and we go back 270, that would tell us, okay, we're pointing south. So yeah, we'll do something like that. If turn direction equals L, then value gets like negative value, because we're going counterclockwise in that case. So that'll make sure we can just add our value down here. So we'll say current degrees value mod 360 is new degrees, new degrees. Oops. Okay, couple typos I fixed there, and up here. Wow, typed it incorrectly everywhere. Okay, so we have our new degrees, and then we just need to look it up again then. So it's more like degrees to heading, and let's say 0 north, 90. We're going to have to use hash rockets for these. East, and still need to call these symbols. 180 is going to be south, and 270 lastly is going to be west. Get rid of that cruft, and we will return digress. Wow. Degrees to heading, new degrees. So we will say heading gets compute new heading R value. Same thing here, L value. So now we have a way of processing all of these instructions. Don't need that anymore. That was just sort of point of reference. And yeah, and I guess this is a private function too. Cool. So with all of that in mind, we can jump back down here. And for all of our directions, where we get a where we get a direction, and I've got the pluralization there, we will say ship dot process instruction. See, we're mixing terms here, but yeah, maybe I'll just update this real quick actually. Okay, so we'll do all of that, and then at the very end we want to ask the ship's Manhattan distance. So let's see. I mean, we're kind of assuming these are 0, 0. Yeah, so I'll continue to assume that. So Manhattan distance will be the absolute x position plus the absolute y position. Assuming starting at 0, 0. That may have to change in a different problem, but this whole thing assumes that we're great. Yeah, I guess let's run it and see what the ship's Manhattan distance is after processing all the instructions. String can't be coerced into integer. Oh, sure. We have to turn each of these captures. Split map, and then we need to map again, where we say direction and value. Or I guess what do we call it up there? Heading and value. And we're just going to return heading and then value to I. And now I think we have something that we can run. Undefined method abs for ship. Line 29. Okay. Huh. Let's see. Maybe absolute value. Maybe I'm thinking of JavaScript when I do that. No, here's abs. Dot abs. Sure. Okay. 25. And is that what we had? 25. Awesome. Let's do it with the full puzzle input. So I'll copy that over to input.txt. Paste that in, 755 lines. Okay, we'll jump back over to part 1 and update which file we're reading from and give this a whirl. 362. Cool, I'm glad that ran without issue. Let's find out if that's an answer that will get us a gold star. And it is. All right, we got 1 gold star for the day. Thanks for watching.